Hi everyone, welcome back to Science with Mr. Fitri. Today we're going to continue learning about geothermal energy today. Still on that same worksheet from last time. So let's get started. Our two objectives here for today are the last two. What is geothermal energy and how does geothermal energy work? So to begin, what we need to understand is that geothermal energy comes from the heat within the Earth. Now, as we learned last term, the center of the Earth, the core, is molten hot. Okay, it is liquid hot metal. And we know that heat moves outwards through the mantle and through the crust due to convection cycles, okay, in the mantle specifically, all right, where that heat rises and the cooler parts of the mantle sink back down. Now, geothermal is derived from the Greek word geo, which means earth, and therme, meaning heat. Okay, and down in the bottom right, you see that Greek spelling. All right. So, the core of the Earth is estimated to be between 2,700 degrees and 6,000 degrees Celsius. Now, geothermal energy is renewable because heat is continuously produced inside of the Earth. Okay? The Earth is hot. It has been hot for millions and millions and millions of years, and it will continue to be hot for millions and millions of years. Now, with geothermal energy, we have to understand that it is expensive to build, but it does little damage to the environment. Okay? How does geothermal energy or geothermal power plants work? Well, geothermal power plants use pipes to inject or to put water into the crust of the Earth. Now, the heat from deep within the crust heats the water, turning it into steam. Now, other pipes bring that steam to the surface where they, again, like other forms of energy, turn a turbine and a generator to produce electricity. So it looks something like this. On the far right, you've got what's called the injection well, where that water is being pushed down into the crust of the Earth. Another pipe on the left-hand side of the picture is bringing that hot water or that steam to the surface. And it is going to spin a turbine and a generator to produce electricity. And then that steam is going to cool back into water and be reused. Okay? So it's going to be a cycle, being pushed down, heated up, brought back to the surface, generating electricity, and then re-injected. Now, you may think, like, how deep do these wells have to be? Well, for that kind of energy or for that kind of system where it's generating steam, they have to be pretty deep. But we've got another system called a geothermal exchange system, and it operates a little differently. What is unique about the Earth is that the temperature about 6 meters below Earth's surface is approximately 10 degrees Celsius year-round. So if we go 6 meters below Earth's surface, it's going to be about 10 degrees Celsius all the time. Okay? So this means that the soil temperature, all right, the ground temperature, is usually warmer than the air in winter and cooler than the air in summer. It's a constant temperature. Okay? It's not going to change at all or by much throughout the year. Okay? So we see this little picture here, and I know this is in Fahrenheit, but I hope you get the right idea. And it kind of mimics where I am from in America. So you see the summer side of the soil there, all right? In the summer, it may be 90 degrees Fahrenheit, so like 35 degrees Celsius. Okay, quite hot. But if we go deeper in the earth, okay, about 6 meters, we see that it maintains about a 45 degree Fahrenheit temperature. So maybe like 10 to 15 degrees Celsius. And that's going to be throughout the year. Now, in the winter time, as you see, we have 0 degrees Fahrenheit, okay? Freezing temperatures, all right? Very cold, especially for Thailand. But again, if we dig down about 6 meters, you see that the constant temperature remains 45 degrees Fahrenheit or 10 to 15 degrees Celsius. All right? So that constant temperature is not going to change whether it's 90 degrees Fahrenheit in the summer or 0 degrees Fahrenheit in the winter. And that's going to be unique. Let's check it out. So what happens with a geothermal exchange system is that it uses pipes buried below the surface of the earth, okay? And a liquid circulates through these underground pipes where it is heated in the winter and cooled in the summer. And that liquid returns to the surface where it circulates to heat or cool a building. So something like this. And this would mimic a winter scenario. Okay, so we've got those pipes buried below the surface of the earth. In the winter, that cool water, or cool fluid, is piped out of the building down below the ground, and as it moves through the pipes, you see it gets warmer and warmer and warmer. Now that warm liquid or fluid then gets returned to the building where it is used to heat the building. So it's using that constant temperature of the ground to heat a liquid and warm a building. Now, on your worksheet, you have these two boxes, and I want you, to the best of your ability, draw these pictures. Okay, so the first piece, a geothermal exchange in summer. Okay, so if you can, let's draw a little house, okay, with our heat pump, as it's called. Now it's taking that warm fluid or liquid and it's pumping it down below the ground. Below the ground, it is cooler than in the summer. So it's cooling that fluid or liquid and then recirculating it through the house. Okay? So the ground is absorbing that hot liquid or hot fluid, okay, and returning to the home a cooler fluid. And in the process, it's going to cool the home. In the winter, okay, the same system is going to pump out a cool liquid. It's going to go down below the surface of the earth. The surface of the earth being hotter than the outside of the earth. The interior of the earth being hotter than the surface of the earth is going to warm up that liquid, return it to the home where that hotter liquid is going to be used to heat the home. Okay, so if you can draw these pictures, that would be great. Now these, just as an overview, these systems aren't going to be able, or aren't maybe effective everywhere. But if we think about this, if we have an area of the world where it's hot in the summer, cool in the winter, and by just using the natural constant temperature of the Earth 6 meters below the surface, we could significantly cool a home in the summer or heat a home in the winter, and the only energy that's required is pushing that fluid through the pipes. Okay, everything else is kind of a natural process. Really, not much energy is needed to heat up or cool down the home. We're using the natural temperature of the earth to do it. So again, I hope I've done a good job of telling you what geothermal energy is and how it works. Okay? Again, if you would like to do more research on how it works, some examples from around the world, a great example is the country of Iceland. They've done a lot of work on geothermal energy. Maybe you could think about that for your project. So, ladies, thanks again. I hope you have a good day and good luck.